Hello, welcome to the RISC 2020 poster session. My name is Tianjian Huang, and now I'm presenting you my research. The title is Using Process Mining to Analyze Children's Interactions with RoboTutor. Engagement is a critical factor in learning. Many scientists are motivated to detect whether students are engaged in learning processes. Previous work used facial expression, body posture, machine learning methods, etc. to infer engagement. Those approaches depend on specific hardware sensor and they rely on accurately labeled data. Our study presents an educational process mining approach to analyze student behaviors on RoboTutor log data and detect student engagement. To be brief, EPM is a new technology emerging from educational data mining. It analyzes log data gathered from the educational environment and provides insights into educational processes. Before we get into the approach, let me briefly introduce RoboTutor. RoboTutor is an Android tablet tutoring app in the Global Learning X Prize competition. It has several tutoring programs that teach students literacy and numeracy skills. When it's running, it will generate verbal log files which record users and RoboTutor programs' actions. The study performed EPM approach as follows. The first stage of EPM is specifying a research goal. During when I specify the definition for engagement and disengagement, and state the research questions on three aspects: completion, duration, and path pattern. And then I converted verbal log into CSV event logs. Finally, I imported CSV file as event logs into the process mining tool Disco and created process models for analysis. Here are the results from analyzing RoboTutor data. And this figure displays the completion status for 10 different tutors. It clearly shows that all 10 tutors suffer from low completion rates. And BPOP add subtutor has a noticeably higher ratio of incompletion with other ending activities. Such ending are not allowed by RoboTutor unless a crash happened. Story read tutor has an extremely low completion rate, and this may indicate the task of this tutor is difficult comparing with other tutors. Then let's look at the case duration analysis. For completed cases, distributions of case durations have clear concentrations, but their location differs by tutor. For uncompleted cases, case duration distributions have two distinctive features. First, most of the cases ended almost immediately. Second, a few extreme outliers have very long durations. Finally, let's look at the path pattern analysis. For completed cases, the straight correct cases are the most common, except for story read. Combined with the results from completion rate analysis, it is likely that story read tutor suffers from a high force rejection issue. For uncompleted cases, hitting back button before the problems showed up is the most frequent pattern, indicating that students feel bored or the tutors are not interesting enough. In conclusion, this study shows that EPM can help in understanding student engagement behaviors and discovering potential aspects to be improved. In the case of RoboTutor, EPM approach discovered crash issue, force rejection issue, and completion issue. Developers can clearly see where those issues happened and thus make adjustments to RoboTutor. However, this study only shows EPM with this goal has value on analyzing RoboTutor log data. Further studies can focus on using other tools or finding a universal framework for more general real-life processes. I would like to thank Dr. Ann, Dr. Christian, and Nirmal Patel. Without their kind assistance, this study will not be able to complete. Also, I would like to thank the RoboTutor team and the RISC community.